We're going to be talking about data explosion. So expect some G-forces. We got Don from the Redline Performance Solutions, right? Don actually started his career at IBM, did a lot of exciting stuff. And then Desiree Kemble from Microsoft. Desiree started her career doing geology. So I thought that was pretty exciting. And then Chuck Gilbert from AMD. He's a technical director in solutions architecture. And why don't we do something similar? Just do a quick kickoff on your favorite quote and a little bit more about yourself.
Sure. So a little bit about myself. Let's see. Well, I've been running Redline for the last 25 years, and this is really close.
We hear you.
Yeah. All right. And been working in HPC for the majority of my career. Really enjoy it. Got 3 kids, and my quote is from St. Francis de Sales: "Be who you are and be that well." My girls went to a Salesian school, and so it really resonates with me. So, thank you.
Thank you. Welcome.
It's such a pleasure to be here tonight, and thank you to Rescale for including me with my panelists. I work for Microsoft, one of the most innovative companies on the planet. I've worked there for 2.5 years, and it's just a thrill to be there. The quote that I picked tonight is really related to what it takes to be innovative. And it'll be interesting to see if anybody recognizes it. I'm going to get one word wrong. To succeed is not permanent. To fail is not a failure. The only thing that it matters is to have the courage to continue. So very slightly screwed up from Winston Churchill.
No, that was worth the wait for it. Thank you, Desiree. Chuck.
So Chuck Gilbert from AMD. I'm a technical director for solutions architecture. I'm part of the architecture and strategy team, which is really focused on kind of the next 3 to 5 years of where we kind of see the business going based on our customer workloads and how we meet kind of the fusion of software and hardware. My background, long-time history of being in HPC. Started my career out working for Raytheon, supporting the U.S. intelligence community. I ran a supercomputing center at Penn State University for a number of years. And I was also in the office of the CTO at Dell. For my quote, it's not necessarily a direct quote, but I think often to John F. Kennedy whenever we were looking for the Apollo space race. And he said, quite eloquently, that we choose to go to the moon at the end of the decade, not because it's easy, but because it's hard. And so I think of everybody here in this room and all the things that we deal with on a daily basis that we do the heavy lift, whether it is, as being an IT solution provider or in industry. We're doing a lot of hard work and we do a lot of innovation, and we don't do it because it's easy. We do it because it's challenging, and we do it because we want to help customers. So,
awesome. Thank you. Nice quote. Thanks, Chuck. All right, so we'll get right into the questions. I mean, clearly these guys, you've all done stuff you can't talk about. Because you were at Raytheon, you did a lot of Defense Department stuff, and who knows what Redline's been up to, right?
Oh, yeah.
So,
yeah, exactly. We don't want to talk about the weather.
Let's talk about the things we can talk about. So, clearly with simulation use rising, and it's been happening for many years now, and then you add on top of that the need to do even more simulation, sometimes in conjunction with AI and ML, we're seeing a data explosion, right? What are the challenges you guys are hearing from organizations on being able to grapple and manage this data?
So I'll go first. Our customers are really struggling in many ways. The data is exploding, the part of the question, but they don't know how to grapple with making sure that they have data integrity, that they're not paying an arm and a leg for storage. If you think about what you can do with that data, if you have conflicting data, if you have old data, if you have duplicate data, it can be expensive to try to run analytics on it. It can destroy the integrity if you have conflicting data. And then most importantly, they have data in all sorts of different places. So how do you pull it together to be able to do any AI, ML analytics on it? And so they're really struggling with that. This isn't a new issue. This idea of data pillars or silos is something that's been around a while. And one of the solutions, and of course I work in Azure, is you throw your data into the cloud so that everybody can access it. You keep it in the same place. You implement data retention rules. You train your staff. You make sure you're constantly purging, not when you need to do something, but when is an ongoing process. And that's really an education that folks haven't gotten used to because there's shadow IT everywhere. Somebody has a server underneath a desk and they have everything in their computer and they don't want to share it. Our coders don't want to back things up at night. And so I think that we're at an inflection point as corporations, but the next inflection point has to be the actual individuals and corporations turning the corner and learning how to deal with data as an asset that doesn't have to be hoarded and kept forever, but needs to be refreshed and kept integral.
Okay. I'll offer my thoughts on it. I mean, my perspective is going to be coming from the National Weather Service, right? And running again, we've run operations for the Weather Service for the last 23 years, and don't blame us for the forecast, right? You get a forecast, that's our job, right? But suffice to say, NOAA's brought online all these new satellites, right? And the amount of data now that we're ingesting into these models is, quite frankly, too much for the models themselves. And so we end up with a lot of data that's just not used, right? And we can't do anything with it later because nobody cares about yesterday's weather. And so where we see a big potential for AI and ML is the idea of using AI and ML to train and look and do quality control on the data so that when we make sure that the data that we are ingesting is the most valuable data for the model. But it's going to take a while, right? Because this is, these are very old codes, right? And it's a mindset that doesn't quite understand this yet, myself included, by the way.
Sure. Any thoughts from you, Sean?
No, I agree 100%. And I think, the last panel that you just had talking about domain-specific architectures and where that's going to play into all of this, we're going to have to start processing data on its flight path into wherever it's going to be stored. Every piece of data that's generated, you just think of just from autonomous vehicles or even the human genome and all the different runs that go across the board. We can't keep storing and copying this data all over the place. So we're going to have to, move the processing closer to the data sources and then make sure that we're only passing along and storing what makes sense to even keep. Because as we think about our houses now, I mean, even our washing machines and our dryers are connected to the internet and sending signals.
Yeah.
I think it's hilarious that, I like to jokingly say that I'm probably the only true hyperscaler in here. I have 8 kids, ages 13 and under. So, one of the other things that's interesting is like...
I thought that was a typo when I said
No, that's not a typo, no. But one of the things that's really interesting is like I can even take my smartphone and, if you can't tell also, I'm from Texas. I got the boots on.
track your kids?
What's that?
Is that what you're saying?
No, not the kids.
Okay,
but
sorry.
there's a place there called Papa Murphy's, which makes take and bake pizza. Right, you can get it from Walmart, and you can be on the way home, the kids screaming in the back of the vehicle, and I can turn my oven on from my cell phone.
Yeah.
And it preheats before I get home to cook my pizza. Right.
Yeah.
So there's a lot of data that's being sent back and forth, and the more things that are on the grid, the more things that are processing, we're going to have to be able to know what we're going to keep and throw out closer to the sources of those data, because we're already talking about 400, 800 and beyond gig networking at this conference. At some point, it's going to get impossible to keep these pipes going that much larger.
You're reminding me of a scare I had a while back. So I've been using the Roomba robotic vacuum since the very beginning.
It sucked up one of your kids?
No, it's just one time. I'm upgrading as the years go by, and one time I'm cleaning it, and there's a camera facing me. And I thought, what? Why does the freaking Roomba need a camera? That was a little creepy. Anyways, moving on. So we talked about explosion of data. One challenge many organizations have, and certainly customers we have at Rescale, we talk to them about their data challenges. And a lot of it is around how there's lack of shared access to data. And even if you have access to data, there's lack of shared context. Like, was this the right simulation to use for the work? Desiree, you talked about the fragmentation of data in organizations. How are companies trying to get better at this?
So one of my favorite examples about this is during the pandemic. An oil company of ours, very large, you probably pull into their gas stations all the time. An oil company that's a client. During the pandemic, they really struggled because they did their workloads for things like geophysical or seismic simulation. They did it on supercomputers that they had in their own data centers. And with the lack of people flying, they couldn't get the teams from around the globe to be able to collaborate. And so they were stuck with the people who were in that individual regional area. Maybe they could drive, but they weren't going to fly. And it really impacted their ability to determine where they were going to put their wells and how they were going to generate their revenue. We talked them into bursting into the cloud and putting some of that data in the cloud. And the biggest benefit that they discovered from their perspective, we weren't really expecting this, was all of a sudden, once again, they could collaborate globally. The data was accessible. And you might say, well, wasn't that supercomputer and the high-performance computing they did on the national network? And it isn't. I mean, so many of these are not. They're very local. It's not like your email. And so they found that that ability to collaborate was one of the best things that they got out of the cloud. And so the data's there, accessible, data anywhere, data time, collaboration, and that's one of the things that we recommend to our clients. There are reasons sometimes to have on-premises supercomputers, and there are certainly reasons to have cloud, but in terms of being able to take multiple workloads that keep shifting, teams dispersed globally, varied teams that Microsoft's extremely virtual. Who I work with on one day might be different than who I work with on another. If we weren't enabled by the cloud, it wouldn't happen. So whether it's high-performance computing workloads or AI workloads, I think that that's the way of the future.
Makes sense.
Interesting. Yeah. So an example that I can give is with weather modeling, right? Community modeling is something we've been in the weather stuff been working towards, but it becomes very problematic to get a PhD at a university on our systems, right? A lot of clearance, so that maybe they get a grant for a year, and it takes them 9 months to get access to that system, and then they don't have that time. So Noah started a program called EPIC. I think Raytheon's the prime on that one that we work. And the idea is to take these models and containerize them and make them cloud ready, right? So that then you get that grant, and maybe you'll get some time, and you can bring that up in the cloud, and you can do your research in the cloud, and then send those results and bring it into the community, because you really can't have community modeling with a closed system. And the cloud has really made a big difference and is enabling that for us.
Got it. Chuck, what do you
I
think?
go back to my time even being at the university and seeing the challenges that faculty members had. Kind of the point of hard drives sitting under their desks or cluster in a closet somewhere. And one of the things was two big things that rang true was one, having access to centralized pool of data with a true verifiable immutable copy. Right, so thinking of some of the genomic processes happening, the human genome's known. We don't need 20 to 30 to 40 copies of it sitting around the same parallel file system inside of an HPC center, although it does happen quite often. But that's one thing. So that's a big piece of it. What can be immutable data sets that's shared, that that multiple jobs can run on simultaneously. The other piece is reproducibility. So talking about containerization or virtual machines, packaging up not only the code, but the data that's used in order to provide, a simulation and results, being able to upload that to the cloud, to other HPC centers, and then being able to archive that and then potentially retrieve that. It's a big thing, especially the National Science Foundation has talked a lot about, is with the, kind of the data retention policies and kind of these unspoken, unwritten rules that are going into federal grants, that you've got to keep the data and the processing and all of this to be able to reproduce for a number of years. Right. But by the way, we're not going to give you the funding to do it. Right, so there's a lot of challenges that are being done. So reproducibility is another big part of that.
Got it. Okay, let's shift on to our last question. What of all the things you're seeing around, data-driven engineering in the computing, scientific computing and engineering space, what's the most exciting or most promising use cases you guys are seeing?
Yeah, so for me personally, and it's going to steal a little bit of thunder from my talk at the end, but I think personalized medicine is really interesting. So I suffer from arthritis since I've been 16 years old, and I think about some of the advances that can come from crossing my medications that I'm taking, the exercise I'm doing, how much water I'm drinking, and kind of building that personalized profile to be able to help me not only treat the symptoms but manage the disease long term. And so I think that's going to be crucial especially as we see just, the cost skyrocketing of pretty much everything, right? Our medicines, doctor visits, everything's getting more expensive. And so in order to keep those costs controlled, we're going to have to really know more about ourselves deeply and be able to monitor that in more real time. So I think that's going to be a big advance that's going to really help, improve the overall human quality of life and hopefully reduce overall hospitalizations and medications longer term.
Interesting. Cool.
I'm going to put a little bit of a twist on the question. It's less about a use case and more about making use cases work better. One of our clients, medical example as well, because medicine means everything to the quality of our lives. They do cancer research for children. And we help them move their workloads into the cloud. The average term for a research run went from 100 days to 1 day. Say even that's off by 100%, it's 2 days. So it's 50 times faster or it's 100 times faster. That you can do that 50 to 100 times faster, determine which trials are not going to work, which is a dead end, what is possible. And that means in the end, we're 50 to 100 times faster for finding cures for certain types of cancer for children. And when my family and my friends who don't understand HPC, they don't understand what me or my team do at all, when they ask for, well, what do you really do? This is the example I love to give them because it means something to all of you, to people who have children or who have people who are in your community who are sick. And the power of cloud to be able to enable companies and institutions and organizations to do things faster, to do things better, or to do things that they've never been able to do before is what gets me up every single day and excited about going to work.
Wow, Desiree. Wow. Compare that noble comment to my comment earlier about getting engineers more dates. It's just I feel weird. Don, what do you see?
I don't know. I take it. I'll take it in this direction. So I've been coming to this conference for the best part of 20 years, right? And one of the things me and my business partner we like to do is we like to walk the edge of the show, yes. Right? And you see the tiny booths, right? And the guys, and then over 20 years, you watch how they come into the middle.
Yeah, absolutely.
But then you start to think about the folks that were in the middle, and where are they? Mm-hmm. And they're gone. And this is just this cycle of always again. So you see a void in this market, and not for long, right? It just keeps coming in, and the innovation. We saw a few cloud providers, right? We had, you had the big guys, right? Mm-hmm. And now you've got so many, right? Yeah. More out there, and to your point, specialized, right? When 5-6 years ago, right, when you said I'm going to do HPC in the cloud, and I was like, you're not going to do my HPC in the cloud, right? Yeah. And we did, right? We worked with Rescale, and we ran, our global forecast model on all the platforms, right? And so. What was didn't seem feasible, and it's just amazing to see all these new companies that are showing up every day. All right, it's fantastic.
It's been fantastic. I remember when I first got my Rescale offer, and I thought about joining the company, and then I accepted, and I talked to some of my friends in the national labs. Mm-hmm. They're like, you can't do HPC in the cloud. That's complicated stuff, right? And sometimes I look back, and I'm old enough to remember a time when people thought you couldn't do CRM in the cloud because that's critical sales data. You can't put that in the cloud, right? So for folks that say, well, you can't do engineering simulation because that's critical information, it's just a life cycle that's just moving a little bit slower, but still definitely moving in that direction.
Yep, I agree.
Awesome. Well, thank you so much for your insights.
Yeah, thank you.